This is Brian Putt. Today I want to talk to you about the COVID-19 testing. We have an epidemic going on, and bad things are happening. Businesses are being shut down. And the question is, are we properly reporting the number of COVID cases? So I want to look at the reliability of the testing, which really involves the reliability of flu and COVID-19 testing. So as background, every year we have the flu. The CDC estimated that at least 12,000 people died from the flu between October 1st and February 1st. And the number of deaths could be as high as 30,000. They also estimated that 31 million people caught the flu this season, with 210 to 270,000 flu sufferers actually going to the hospital. So this information demonstrates the number of people that are getting the flu and the number of people that die from it. It's a very large number relative to the number of COVID cases that have been reported. And the number of flu cases has occurred even though millions of flu vaccines were given in the U.S. So the question becomes whether we are properly differentiating between the flu and the COVID-19 virus. So let's talk about the percent of the population with the COVID-19 versus the flu. Using 290 hospitalizations for flu between October and February would imply a hospitalization rate of 2358 per day. And I had a statistic down here in the bottom right showing 1336 confirmed COVID cases, and that was through March 12th. I actually understand that there's 24,000 cases now through March 21st, so exponential growth there, which is what people are talking about. But is that exponential growth of really COVID, or is that exponential growth of saying that you have COVID and you really have some sort of flu? Anyway, using these numbers, we'll come back and look at the sensitivity of this number later on. The percent of COVID-19 cases is 1.85%. So it's 44 divided by the 2553. So what is the flu test reliability? This is not easy to find. And I've shared the model or discussed this with others, and they said, well, I don't have anything better. So let's go with this, and if we find something better, we can always substitute that into the model. But the way the COVID testing goes is they test for flu first. And then only if the flu is negative do they then test for COVID. If the flu is positive, they say, you've got the flu, go home. Therefore, we're relying on a good flu test to weed out the flu victims before we test them for COVID. So the CDC estimates that this rapid influenza testing, and I guess there's more advanced testing that you can do, but it takes longer, it's probably more expensive, has a sensitivity range from approximately 50 to 70. That means that up to half of the influenza cases will still be negative. And another study in Turkey showed that the sensitivity to rapid influenza cases for H1N1 ranged from 31 to 50%. Let's look at the reliability of the COVID testing. We're also relying on this to identify who has COVID so we can put them in isolation for 14 days. But according to the report below, COVID is highly unreliable. If we look at this bottom report, it says after clinical examinations, the doctor believes that the patient has 50% probability of having COVID. He knows that diagnostic test is unreliable with a 40% sensitivity and a 90% specificity. So what does that mean? So the sensitivity is the probability of a positive result given that they're infected. So given that they have COVID, it'll give a positive result 40% of the time. And the specificity is 90 to 95%. So it's really, really good, which means that you get a negative result if the person does not have COVID. So that 90% to 95 is a really good number, but this is kind of troublesome here. So this is what I used in the model. It's got 64% for sensitivity on the flu and 40% on sensitivity for the COVID. And you can see the specificity of COVID is the 95%, and I only used 67% for the flu. And we're going to use 1.85% initially here, and then we'll look at some sensitivities of that. Okay? So let's think about this in the influence diagram, and I'm going to talk about the results at the same time. So what happened is, does the individual have flu? And this is reality, if you will. And what we said is that 1.85% of the people, or if I talked about 10,000 people, 185 out of 10,000 would have the COVID-19. And I'm going to give them a flu test. Of those that go home, 59%, or 59 of the 10,000, would have COVID, and 6,340 would actually have the flu. Now, there's going to be some that have the negative result. And if we just look at the remainder, 488 will be identified as having COVID, and there'll be 164 that actually have flu. And they're going to go home, they're going to go back into the 14-day isolation. And then there's a bunch that are they're going to have negative results on both. 78 out of 10,000 will have COVID, and 3,311 will have the flu. And I don't know what you do with them. Do you send them home, or do you isolate them? It's a lot of people. You're probably going to send them home because you don't know what they have. You assume they have something else. So let's look at the sensitivity to the actual COVID-19 population. Remember I said it was 1.85. That's over here. That 24,000 number actually turns out to be more like 24%. So it's off this chart. But as you can see, what's happening here is thought to be flu, identified as COVID-19 as the blue. That's actually the lowest number. And if we just extend this out to 24, you can see what happens. It's still a low number relative to the total. At 10%, it's only, call it 2.8% of the 10. Now, what's really difficult to swallow here is unknown but COVID. And so that's this light gray line. That's the top line. And what that means is if we don't know what they have, we're probably going to send them home, but in reality, they have COVID. Okay? And then this is the number that are thought to have flu. And so if we think they have flu from the flu test, we're going to send them home as well. The only ones we actually capture here are is this blue line. The rest of these are just going home or probably. And then there's a bunch of people that test negative for both and have the flu. And that's independent of the probability of the population. You can think about that as being, if I got rid of all the COVID-19 cases and I still ran them through the flu and the COVID test, because of the false negative and false positive, that's a pretty constant number. So there are some other alternatives. Rather than doing the flu test first and then doing the COVID test, why don't we just do the COVID test first? Does that give us a different answer? And the answer is it does. So assuming the same 1.85% coming in here of COVIDs, we capture 71 COVIDs are isolated, send home 36 COVIDs, and we still have 78 COVIDs that are unknown because they tested negative for both flu and for COVID. Let me summarize that a little bit here. I just wanted to give you the flavor of that. So here's the summary using the 1.85. Here's the 1.85. And the ones I want to focus on here are the ones with COVID, which are the flesh-colored. So I've got, if the flu test is first, it's 1.37 that go home with COVID. And if I do the COVID test first, it's only 1.14. That's good. On the 14-day isolation, I also get better with 0.71. The downside of this, of doing the COVID first, which is what I think we're probably going to end up doing with the drive-bys, is we're going to have more and more people in isolation when they really only have the flu. It goes from 1.64 to 4.97. And doing both tests doesn't have any impact. That is what I wanted to show you, discuss. There's certainly more that can be done. All the numbers are uncertain. So let me go over the model here, and let's try that 24% in the model. Here's my model, and here are the conditional probability matrices. For the flu, if I have the flu, there's a 64% chance I'll say yes. And if I don't have the flu, I'll see that, say no, 67% of the time. So these are the errors. These are the false negatives and the false positives. Similarly for the COVID test, down here you can see it's much more accurate, telling me I don't have COVID. And I'll tell you what I'm going to do. I'm going to split my screen here. And we'll run down here to that number, the 1336. And we're going to change that to 2400. So let's take these results. I'm going to copy these and paste over here as values so we can compare it. I'm going to put 24,000 in here. And it comes up to 25% COVID. And what we see is we can compare these two tables, that the number of people going home with COVID is now increased to 18%. That's a bad outcome. And we've only captured about 7% of those if we do the flu test first. We only capture 10% if we just do the COVID. The number of people with the flu going home does not increase radically. So that's good. So I hope you found this informative. I'm sure we're going to work through this COVID epidemic, and we'll come out of it better with tests, vaccines for COVID, so we don't have this in the future. Thank you for watching. This is Brian Putt. You can reach me at brian@theputts.com. Thank you.